Let's look at proposition number 36 of book 9 of Euclid's Elements. The proposition says, if as many numbers as we please, beginning from a unit, are set out continuously in double proportion until the sum of all becomes prime, and if the sum multiplied into the last makes some number, then the product is perfect. So what the proposition is saying is that we set out numbers A, B, C, D in double proportion, starting from a unit. And these numbers, the multitude is such that the sum of these is a prime number. Then if we multiply the sum of all these with the last number, then that number is going to be a perfect number. So here, first thing, let's understand what is perfect number. I'm saying 28 is a perfect number. What are its factors? Its parts or factors are 1, 2, 4, 7, 14. Now, if we sum up all these, what do we get? We get 28. So a number whose factors sum up to itself is a perfect number. And what this proposition is saying or talking of is generating or finding this perfect numbers. When we say double proportion, basically what we mean is we start with 2, double it, double it, double it. So this is 2, this will be 2 square. This will be 2 square times 2, that is 2 cube. This will be 2 to the power of 4. So we continuously keep doing it. And here, E is the sum of all these. Now, you might have noticed that this doesn't look like it is a sum of all these. That is because if I actually draw the sum, then this will be a big number. Let's say this big. But later I'm going to generate these. So those will be so big that it will go off the screen. So the E and these are not in proper scale. So when I say E is equal to A plus B plus C plus D, don't compare the length of the lines. So let's begin. We have to prove that FG, which is the product of the sum of these numbers with the last number, is a perfect number, where A, B, C, D are in continuous doubling proportion, and the sum of them, that is E, is a prime number. So given U, A, B, C, D in double proportion, or rather more appropriately, A, B, C, D in double proportion starting from the unit, such that E is equal to U plus A plus B plus C plus D is a prime number. And let Fg equal to E times D. So now the claim is that Fg is a perfect number. Take E, H, K, L, M equal in multitude and in double proportion. So basically we generate another continued proportion, which is a double proportion, and we generate as many numbers as there were in the original sequence. Okay, so E, H, K, L, M are 4 numbers, and originally we had 4. Now, since these are double proportion and these are also double proportion, so they are in double proportion and they are equal in multitude. X equally, we can say A is to D as E is to M. This proportion can be written in product form. E times D is equal to A times M. Product of the extremes is equal to the product of means. Here, Fg is equal to E times D. and E times D is equal to A times M. So that means Fg is also equal to A times M. A times M. That means M measures Fg according to the units in A. How many units are there? 2. So that means Fg is double of M. E, Hk, Lm are continually doubling, and we are saying that Fg is also doubling with from M. So which means we can incorporate it into the continued proportion. So E, Hk, L, M, Fg are in continued proportion in double proportion. Remember the previous proposition where we saw how to sum up a sequence? So subtract from Hk and Fg, that is the second and the last, the number E, that is the first number in the sequence. So let me incorporate it. So Hn is equal to E, Fo is equal to E. Excess, previous proposition says the excess of Hk after subtraction, that is Nk is to E, is equal to Og, the excess of the last after subtraction, is to the sum of the previous, and sum of the previous numbers is M plus L plus Hk plus E. Nk is equal to E. Now it doesn't look like Nk is equal to E. That is because this is not as per scale, because if I draw it at scale, these lines will go off the screen. So I have not done as per scale. But you can think about it and realize that Nk is actually equal to E. Because remember, Hk is double of E, and I'm subtracting this from this. So that means the remainder will also be equal to E. So Nk is equal to E. So Og will also be equal to M plus L plus Hk plus E. But Fo is also equal to E, and E is equal to U plus A plus B plus C plus D. Right? E is equal to this. So which means we can say Fg is equal to Fo plus Og, which is equal to the entire thing. U plus A plus B plus C plus D plus E plus Hk plus L plus M. So here Fg is equal to Fo plus Og, right? Fo is equal to E, which is in turn equal to U plus A plus B plus C plus D plus Og. Og is M plus L plus Hk plus E. Okay. So which means Fg is measured by all these numbers. Yes. So we have a perfect number. So Fg is a perfect number. Why? Because we are saying that Fg is measured by all these numbers. That means they are the factors of Fg. And we have seen that their sum is equal to Fg. The other part of the proof is to show that these are the only numbers that are factors of Fg. There are no other number which will measure Fg. So let's do that. To prove that these are the only factors of Fg, let's assume a contradictory statement, that there is some other number P which is a factor of Fg, and prove that this is not possible. So proof by contradiction. Let P measure Fg according to Q. So if you multiply these two, we will get Fg. And P should not be equal to any of these numbers. So it must be some other number other than these. Which means Fg is equal to P times Q. We know Fg is equal to E times D. That means E times D is equal to P times Q, which can be written as a proportion. E is to Q as P is to D. And basically, we know that D is not measured by other number except ABC. This is one of our previous propositions where we saw that in a continued proportion, D will not be measured by any other number except those appearing in the continued proportion. So D will be measured only by A, B, C. That means P does not measure D, which means based on the proportion, E also does not measure Q. That means E and Q are relatively prime. Based on this proportion itself, we can say that E measures P the same number of times that Q measures D. So E measures P same number of times as Q measures D. But we know D is measured by ABC, any one of them. So that means Q is also measured by ABC. Now let's take any one. So let's say Q is equal to B. Take EHKL equal in multitude to BCD. EHKL equal in multitude to BCD. That means X equally B is to D as E is to L. And in product form, we can write it as B times L is equal to E times G. But P times Q is FG. E times D is also FG. And E times D is equal to P times Q. So which means B times L is also equal to P times Q, which can be written in proportional form. Q is to B as L is to P. We have already said Q is equal to B. So that means if Q is equal to B, that means L is also equal to P, which is not possible since P is not supposed to be equal to any of these and L is one of these. So P cannot be L. So which means no number measures FG other than this. So here we said let Q equal to B. You can take any of these A, B, C. So we have proved that FG cannot be measured by any other number other than this. So that is proposition number 36, which by the way is the last proposition in book 9 of Euclid's Elements. Let me remind you again, there is a link to a PDF book which describes all these propositions in detail. Please feel free to download it, refer to it, and if you think somebody else can also benefit from it, please do share. That's it for now.